Okay, what am I doing? I'm making tic tac toe because I want to do that, and you can't stop me. And I think it would be a good way to kind of flex my muscles, learn Haskell, cry a little bit, get my mind off some things. So if you have any questions about what I'm writing, what it means, what it does, just comment them. You know, do that thing that people do. It'd be cool. Right. So what do I want to do? First off, I need to make the main. So this is going to be that. Alright. So I'm going to talk out loud about what I want to do, and I'm going to be talking a lot about how I would usually do this in an imperative language like Python. So, okay. Here's some of the things. I'm going to make a really sectioned off point. So this is a multi-line comment. In Python, something I would do is I would have the board of the game as like an array, right? Something like game board would be something like, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Something like this. Usually, too, I would have this be a list of lists. So it'd be like this, right? So basically, if I was writing this in Python, it would look something like this, right? And I could tell if a space was taken because an integer would be in that place. And I would have something like, I would have a main program and it just switches between X's and O's and it would fill in these spaces. Problem is, I can't directly change the game board in Haskell because that would be manipulating state and changing variables and all that stuff, and that's illegal. So what I think I'm going to do is I think instead we're going to represent a board as going to be basically a bunch of imaginary pieces. So it'd be like piece 1, piece 1, it'd be like piece 1, piece 2, ... piece 9, right? So basically we're going to have a list of pieces from 1 to 9. But when we change the piece to be an X and O, it would, be like piece X, piece O. So what I want to do is I guess I'm going to make a type called piece. And so what this is going to be is this is going to represent the different kind of pieces that we can have on the board. So we can have this be an open space, which will have an integer with it, I guess. Or this can be I guess maybe a player with a character, right? Here, let's see, type a char. Yeah, okay. So this will be an open piece has an integer. It's so it'll be 1 plus index, and then you can have a player piece which is X or O, right? Something like this. And then I want to do deriving derive, I think, is it derive or deriving? Deriving? Yeah, so it's deriving, I don't know things. Deriving show and EQ, right? Basically what this single line right here is saying is I want Haskell to basically come up with some code to be able to turn this data type into a string and to also come up with some code for comparing these types, right? So now, if I compile this, it doesn't work. Okay, now that we have solved the problem, this will be epic. It is epic, Alistair. I'm glad that you asked. Okay, so the problem was I was using type and not data, and those are completely different things. But now it works. Okay, so sweet, Alistair. What does this mean? Well, we could have something like piece 1, piece integer. Yeah, open 1. There we go. I don't know if I like that. So an open space, we have an open space with 1, and we open 2, open 3, open 4, open. God, open does not look like a word anymore. Je m'avoue, open 7, open 8, open 9. Cool. And if I change this to a player of X, okay. I should try to actually say the things that are coming in my head. So when I want to print out to the user the game board, right? I want to be able to put out a single character like 1 or O and then 3, but I'm going to need to be able to put out single characters, like the single characters. So I don't quite want the show to just, instead of saying 1, O, 3, to say open 1 and, player 0 and open 3, because 1, that's stupid and that's not how tic-tac-toe works. So I think it's like something like instance show piece, where I think it's something like this, where show of open n is show n, right? And show a player of some character is show 0. Oh, actually, okay, yeah, okay. What's the type signature of show? Take something, makes it a string. Okay. Here. We'll be a little sneaky. We'll do this. Should this work? No, of course not. Why would that work? Constructor open should have 1 argument, but has been given none. Independent show open and in the equations for show have 2. What? Oh! Parentheses, y'all. Parentheses. Tell me how I should be. There we go. All's right with the world. Reload that. So now if I do show open, so an open spot 1, it just gives me 1, and show a player of O, that's just O. Bingo, bongo. Yes. Excellent. So is of player O equal to another player of X? That is false. Is a player of O equal to an open 1? That is also false. Is open 1 equal to open 1 and 2? False. Okay. Cool. So this is going good. What did I just do? I'll explain real quick. So basically, if I was to use the built-in, like if I asked Haskell to just give me the code so I can convert these data types into strings, it would not perform the way I wanted to. Because otherwise, if I said, show open 3, instead of it giving back 3, it would give me back open 3, which is not what I want when it's printed. I just want it to say 3. So now when I do show open 3 and we do it, the grouping, it just says 3, right? And this will do the same thing, but for the different character pieces, right? So this is going to be perfect for allowing us to be able to print stuff to the screen. So that is cool. So that's, I'm going to make a little comment. Define show for pieces. So it displays constructor arguments. I'm not quite sure what you would call those. Components, maybe? I don't know. If you know, comment right now. Anyhow, so that's cool. So we did that. We have these pieces. And now I can have a list of pieces as part of our board. And so that's cool. I think I was thinking of having the board be a list of lists of pieces. So it'd be like before we had in Python, you had 3 nested lists where, you have one that represents the top row, one that represents the middle row, and another that is the bottom. But I think, because what I'm thinking I'm going to have to do is I'm thinking I'm going to have to make a function that takes a board and basically chops it in half. How do I mean? So say I want to place, so say if I have a single list, so instead of it being a nested list, the way that these pieces are placed is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it's a single list. If I wanted to change 5 to an X, say, I couldn't just say, oh, take X at the 6th element, and make that, oh my god. I can't just say, oh, the 6th element, which is going to be the 5th, the 5, and turn that into an X. I can't do that. That's illegal. But if I had some function called maybe split at n, or split at nth, so it would take a list and an index, say 5. So say this list here was bound to this variable called list. If I then did list and I want to split it at the 6th element, 0, 1, 2, 3, 4. Oh boy golly, what are you running off to? If I want to split this, say instead of doing n-1, this is the 5th element, right? What it will do is it would give me back a pair of lists. So it'd give me 1, 2, 3, 4, and then also 6, 7, 8, 9. So that 5 in between has been removed, and I effectively have 2 separate lists, right? But then, if I have that, what I could do is I could basically just say, you know, I could have this into some special function called join with piece, and this would take a pair of lists, x's and y's, and a I guess it would be a piece. And what it would do is it would basically just have the x's in front of it, put the piece in a list, a single list, so it can go between these two lists, right? Hopefully that kind of makes sense. So I think that's what I'm going to do. But, whereas in Python, I would have this main function basically be an infinite loop. I'm not quite sure if I can have main set up as a recursive loop, because that means it's going to need arguments, and I'm not sure if I can do that for main, because that's automatically run by the program. It'll be a whole thing. So instead, I'm going to have a function called, I guess, run tic tac toe. Very imaginative name, I know. But what this will do is it will take a board. Maybe that's something I should do. We'll just say list of pieces. So we'll take a list of pieces, which is going to be otherwise known as a board state, and it will return an IO action, right? So it will print stuff out to the screen. Yeah. So run tic tac toe. This is undefined right now. But what will happen in this function is we're going to get some input. So we're going to actually I think what we're going to do is this function also needs to know who is the player that is placing a piece. Okay? So it's going to take the board state, and it's also going to take a player, right? And this is going to be a piece, I guess. Or, no, for fuck's sake. It will take a board and let's just try it being a single character. And so what this is going to do is it's going to get input. So basically chosen, let's say raw choice. This is really not good variable naming. And it will get the string version or the character version of the choice that wants to be basically because the board is going to be printed out to the user something like 1, 2, 3, 4, 4, 5, 6, 6, 7, 8, 9. Right? It'll be printed out something like this. And so if it's an open space that the player can move their piece into, it'll have a number. Otherwise, it'll be like an X or an O or something. So what we're going to want to do is we're going to want a function that will get input, but it will only allow for inputs for spaces that are not taken. So maybe this would be called something like get piece position, something like that. But once we have that, and this function will also make sure that it's a valid place. So the person isn't saying, oh, I want to place my piece on the place called A. That's not going to work. It needs to be a single digit. Once we do that, we're going to recursively run tic tac. Well, for fuck. We need to check. So we're gonna need an if statement, I guess. Hmm. When I did something similar to this with the rock paper, well, not the rock paper scissors, but with the guessing game, I had the code that basically I had a separate function that would check if the player had won, and if it did, it basically said you won. But if you didn't, as in your number was less than or greater than the number you need to guess, it would recursively call the function that would get input so that it would become an infinite loop. I think we are going to do, I guess, maybe a similar thing. So I guess we'll do something like check yeah, check board state. I guess it would be something like that. And what we're going to pass in is, well, no, we'll get something like new board, and we'll do this by place piece, and it's going to take the board, and then it's going to take the player piece, like this. And then we can do something akin to check board state. And so this will take the new board, and so it'll check the new board that we have, but also this will need to get the raw choice. So this will get check this board state, and it will also pipe in the character of the current player so that we can flip it to the next player. So it'd be something like this, right? We get input, that's a valid thing. We use that to generate a new board which has that piece placed, and then finally we're going to check if anyone's won. And if no one has won and no one has tied, then we're going to recursively call this function again, if that makes sense. I think that makes sense. Yeah. Okay. So let's see. I think first what I want to do is I want to make that function that I mentioned before that splits up at an element. So I guess we'll do it like thus. I guess we'll go split at nth term. This takes a list of A and an integer, and it returns a pair of lists, namely being a list of A's and a list of A's, right? Yeah, but how are we going to do this? Here we go. We want something like A takes an int, produces something like A. Split at. This might be what we want. Split at. Actually, this might be 3 we might be able to use that, right? Split at 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what we want to do is, so we have the fifth element. What we want to do is we want the fifth minus 1 element. But I'm going to change this type signature so it's similar to the other one. But what I'm going to do is remove nth. Actually, I wonder if there's a remove. Let's see. So I'm going to remove to graph. I could be seeing it, but it's not in front of my face, so I don't understand. Okay, so what I'm going to do, remove nth. So we're going to, what are we going to do? We're going to do the left part. We want the left part, so we're going to take an index and a list, which I will just call list. So we want a left portion and we want a right portion that's joined together. And the way we're going to find the left portion is we're going to do, here we'll call x's and y's, and we'll bind that to split at split at the index minus 1 with the list. So now we should have this, right? And then we could say that the left is just going to be, actually we could change this around. So we're going to say that instead of it being x's, this is just what we want, right? Because we removed that. But so that's going to be the left part. And the right bit is going to be everything forward, right? Which would be 5, 6, 7, 8, 9, drop 1. Yeah. So what we're going to do, right, is just going to be drop 1 from y's. And I think that's it. So remove nth. So if I want to remove 1, 2, 1 to 9, I want to remove the fifth thing, right, which would be 5. Lads, I think I've done it. Because look, that's just 1 through 9. Remove the fifth thing, which would be 5 from 1 through 9. I think that's it. Right? That's it. That's it. So removes the nth item, index being n minus 1, from a list. Okay, sweet. Oh my god, that was super cool. I don't know if you guys agree if that was cool, but I think that was really, really rad. So this is great because now I can use this to make a place piece function, I think. So what we're going to do is we're going to say place a piece on a board and some piece. The way that we would do that is we're going to take x's, the piece, we're going to join y's onto it, right? So Yeah, so what the type signature should be place piece. So this is going to be a list of type A. We're going to take A and we're going to produce a list with that on it. Given, oh no, we need an index too. So board place piece in a position. Piece an integer given a board piece an index to place it in, place piece at the position n, index being n minus 1. Okay, so now all I have to do is I have to say that where x's and y's are gotten from remove nth, and so we're going to have the board, and we're going to feed in the index n. So now, theoretically, if I've done my job right, which I haven't, I'm awful. What the hell? Oh, remove nth takes the index first, Alistair. Here, let's index, just so that it's clear. Index. Okay. We take that, place piece aboard. Let's just say piece 1, piece 2, piece 3. And I want to place player O in 0 in the 3rd position. That doesn't work. And I'm really confused. Oh! Okay, I was saying piece when I meant to say open because it's an open spot. This is the problem. There we go. Hey, it worked. Look at that list. I replaced the 3rd position, which was a 3, right? It was an open position with 3 with an O. I did it. Oh my god, we're getting there. We're getting there. So with that, we have a way of placing a piece in a board, and we have a way of crying my eyes out. So now all I have to do is make a way of getting a single digit input, and then ways to check whether or not anyone's won or not. Then we will be on our way. But we're getting there. I'm honestly really happy and surprised that I was able to. When we last left off, I made a way to place a piece on the game board, which honestly I feel super psyched about, and gives me all the warm fuzzies inside. Next up, we need a way to get a piece position. And now that I'm thinking about it, if we want to be able to check if a board position, like if a given input is a valid one, we need a way to, validate that position is not taken. How do we do that? So this is going to need to take the board. Let's do a board And we're gonna call this player, sure, something like that. Really stupid name. But the way we do that is we're going to need to make the function called get piece position, which is going to take a board and it's going to return I think it's an IO, it's going to be an IO int, right? Because we're doing IO stuff because we're getting input, but it's going to be wrapped up in an IO monad, I guess. Get piece position, board, okay. Here. So we're gonna say given a game board, given a game board, what are we going to do? We're going to get a position to place a piece. Get a valid position to place a piece. So, actually, this is going to be undefined for a second longer. I just realized before the player makes their choice, we need to show off the game board. So we're going to do something like put stream ln. We're going to use show board with the board, something like that. So at some point we're also going to need to define show board, which will turn our board into a tic-tac-toe board to be displayed onto the screen. Yeah. Okay, we can worry about that a second later. So, first of all, we're going to get input, right? Raw, we're just going to call this input. Get char, I think that's a type of get char, I think that's a, yeah. So this should be okay. But then we're going to do if the input is an element of the 0 to 9. No, it needs to be 1 to 9. If this is done, we're going to then return read input. Otherwise, what do we want to do? We want to put string ln enter an open position from 1 to 9. We'll do that, and then we're going to recursively call get piece position with the board. I don't know. If input is a single digit, return as int, otherwise get input again. Okay, something like that. Which means now that this function has been implemented, it's been implemented now, y'all. I can do, actually wait, I shouldn't do that anymore. I shouldn't do that, undefined. Okay, but yeah. Get piece position. Transfer to board. What are you talking about, bud? Oh, yeah, board is not a thing that exists. It's a list of pieces. Yeah. Oh, okay. Yeah, okay. I won't question it. I'll accept it. I will accept it. I don't quite understand just yet this whole thing. Get piece position. Oh, no, that's not done. You're wrong. Alistair, you're wrong. Open space. And this will take the board, and it will take this. But now we gotta define what it means for that. Open space. Open space, it's gonna take a board, it's gonna take an index, and if the length of the board, no, that's not how that works. If the length of board is less than index minus 1, then that's just gonna be false. If however, board at the index of index minus 1 here piece is open. If given open with anything, it's true. Piece is open. False. Anything else, it's false. Returns true if piece given is an open piece. Piece is open. This takes a piece and returns a board. Okay, sanity is maintained. I can stay sane. Open space takes a board and an index and returns a boolean. Return true if the index at in this board is open. Index is n minus 1. Okay. Okay. Now, friends, open space board. So, get piece position. Position. Open 1, open 2, and for funsies, let's put player of X. Let's say 0. I don't know what that problem is, but it seems to be working, at least. So I'm just going to continue. So no, still can't, because I need a way of printing out. Board seat first before I can really continue. So, show board. We want to turn this thing into a string. Can I do hello? Yeah, I can. So, what I want to do is, it could be something really stupid. Yeah, I'll just do stupid because I'm not smart. Ugh. Let's see. We'll do show board. A, B, C, D, E, F. Actually, show board line. This will take A, B, C, and some extra bits. And this will just spit out A, show A, conjoin to this, which is going to be show B, conjoin to this, show C. So if I said show board line, and I did open 1 layer X and open 3. Okay. So that's good. Show board line error list must contain at least 3 elements. Okay, so this show board line, a list of pieces and list of pieces, and it will return a string. Makes a single line of 3 items in a board list. Okay, now we'll just be intersperse. I think this is exactly what I want. Border. This is a string. And so it's going to be, I don't know how long. Border is going to be something like 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like 9. Let's say 9. One, two, 3, 4, 5, 6, 7, 8, 9. Border to separate board lines. And so now the function for show board will take a list of pieces and it will produce an almighty string. And actually, let's right. This will produce a string. So show board, it takes the board, and so this will be, we're going to map show board line onto the board, and then we want to intersperse the board. Oh my god, I need a border how do you spell border? I think that's how you spell border. Border. Intersperse that. And then we need to join all that together. Top plus middle plus bottom, where top is equal to show borderline of the board, middle is show board line of drop 3 board, and the bottom is going to be the same thing except for dropping 6. And that should be that. I need to remove this. So we have a single string. This won't work. We don't want a single string. We're going to have this. Let's see more. Load that. Okay. And for fuck's sake, what is this from? Is this from data list? It is. Oh my god, it's from data list. Okay. Top of program, import data.list. Is this going to fix all of my problems under the sun? No, because where does fold R come from? If I did concat, that's what I'm looking for. Not fold. Hold on. I'm looking for concat. That's what I was doing. Concat. Okay. Show board of open 1, open 2, open 3, open 4, open 5, open 6, open 7, open 8, open 9. Almost. If I just did this, I think. Aha, there we go. We have an entire board thing being printed out. Given the board turns that board into a string to print out. Ha ha ha, gamers. We're doing it. We're doing it. Okay, now we can actually start working on the main run tic-tac-toe function. So we're going to do, and we're going to, I'll do this. So now, no, because that's stupid. We can do run tic-tac-toe. But of course not, because it needs that. Of course, run tic-tac-toe. Oh, okay, we're implementing main. Run tic-tac-toe, board, and starting character is X, where the board is open 1, open 2, open 3, open 4, open 5, open 6, open 7, open 8, open 9. Me. Oh my god, it's working, guys. It's working. It's everything I ever would have hoped, and more. Not really. So, next up on the chopping block. This should work, but doesn't. Get piece position. Let's do an debug. Oh, put yeah. Don't know why that bug is there, but it's really bugging me. Haha. Place piece. I should be able to do that. But of course not, because we didn't move that. Right. And this is clearture. And instead of doing that, let's try taking this, and we want to see what the new board looks like. Say place in 5. Hey, that worked, buddies. Folks, I do believe that we have. Oh, and that bug stopped. Folks, I do believe that we are almost on the way of totally winning and being awesome, cool kids. And that's pretty exciting, in my opinion, in my humble, stupid opinion. So, create the new board after placing the player's piece on it. So that's pretty epic. Show current state of. No, I think that's pretty self-explanatory. Okay, so now all we have to do is implement this check board state, and then we basically have a working tic-tac-toe game that actually runs the tic-tac-toe. So this is pretty exciting, if I had to, call tic-tac-toe exciting. So let's see. We are doing things. What do we want to do? We want to implement this checkboard state thing. So this is going to take so it takes a board and a character. So it takes board and I guess we'll call this player character. Undefined check board state. So it takes the pieces, which is a board, and a character, and it returns an IO action. So if x is of 1, okay, wait, I need to do given current character char piece, give other character char piece. So let's just say swap players, and swap players of any swap players of x is going to be O, and swap players of O is going to be X. And swap players of literally any other character is going to be an error. Error, swap players only accepts the characters O or X. Swap players takes a character and changes that to another character. Pretty self-explanatory, and Haskell doesn't cover that. So checks if anyone won. If not, if anyone won / tied. If not, continues game. So basically what we want to do is now we want to see if anyone has won. How do we do that? This is going to be a little tricky. What we're going to do is we're going to make a function to check if a certain player has won a certain way, so vertically. Player won player vertical win. Take a board, take a player, or a piece, I guess, and we're returning a boolean. Right? No, you're wrong, because that's not all. We also need a integer. This is going to be the index, or the position, given a board, player piece, and position on board. Check if the player given one vertically starting of the given position. What do we do? Well, we are doing things of a certain nature. Yep. Player vertical. We have a board, we have a player, we have a position. We want to see if the top part is equal to the player, the middle is equal to the player, and the bottom is equal to the player. So the bottom position, the middle position, and the top position all equal to the player. And what are these values? The top position is going to be, index is going to be the position minus 1. So the top position is going to be the board at the index, the middle position. So if I had a board, so this is going to be the board. I could remove these parentheses. But I could do board. The index is going to be index plus 3, which means that the bottom position will be the same thing, but plus 6, right? That will check if the player won at all given a certain position vertically. Check player check one vertically. Check 1 vertically. Player 1 vertically. If the player 1 vertically, board player, this means that either the player 1, check 1 vertically, board, oh wait, I guess I could do something like or, and the thing we're applying or to is zero, 1, 2, and we're mapping onto that. What are we mapping? Check 1 vertically. The board and player will return true if the player given 1 at all vertically. Okay. Player 1 vertically. This takes a board and a piece, returns a boolean. Okay. So this will be this one will be easy as well. We just need to, actually I wonder, could I wonder if I could just roll that into one definition. That would be kind of nice. Maybe that would be something I'll do later. But this will, given a board, player, and position, check if the player 1 by making a full row of their piece, right? So check 1 horizontally. We're gonna have a piece given, then a list of pieces, a board, a piece, and then an integer, and it's gonna return a boolean. And so to check if someone won horizontally, that means this will take a board, a player, and a position, and it will just basically be first position equal to player, and second position equal to player, and is the third position equal to the player. How do we define these things? Where index is equal to the position minus 1, the first position is well, it'd just be board at the index, and the second position is going to be board at the index right after that, and the third position is going to be the second one after that. Okay, which means will return true if the player given 1 at all horizontally. So we're going to do basically the same thing that we did right before. Player 1 horizontally. This will take a board, a piece, and return a boolean. Player 1 horizontally, board player. So, or map check 1 horizontally. So we'll check if it was 1 horizontally. All we have to do is give the board, the player, and the starting indices, right? There's going to be 0, 3, I think 6, right? A, B, C, D. It's 3 way, yeah. So this should be it. It's compiled. Now the trickiest one is going to be diagonal, right? So I'm wondering, check 1 how do you spell diagonally? I don't know. Diagonally. This is going to be a little different. We're going to have a board, a piece, a starting position, but then also a step. So the last one is basically going to be the amount that we increment by. So to check this, check 1 diagonally. We have a board, we have a player, we have a position, and we have a step. So there's going to be first position. Actually, I might just copy paste this one. I'll delete these. We'll yank this and we'll totally steal that wholesale because I wrote it. Bink, 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 bink. Super cool. Fold that up. Now we can use this and we get to define this ourselves. So where index is going to be the position -1. The first position is going to be the board and the index. The second position is going to be the index plus step. And then the third position is going to be the board plus 2 index plus 2 times the step. And now that should work. Honestly, I could probably reuse this function right here to rewrite all of the other ones. Am I going to do that? Not really, because I'm really lazy. Given board player starting position and step, return true if the next 3 pieces on the board are all the player's piece they won. Yes. So the way that we can do given board player return true if they won at all diagonally. Player 1 diagonally. We have the board and we have the piece and we return a boolean. So this will be true. Player 1 diagonally. If and only if 1 one first diagonal or one second diagonal, where one first diagonal is check one diagonally with check one diagonal, board player 0, 0, 1, 2, 3. Well, no, 3, 4. It needs to be 4. 1 second diagonal is check one diagonally. Check one diagonally. Board player starting at 2, 1, 2, and I think it's adding 2. And that should be that, which means to have 1 given a board and a player, return true if they won at all. If so, player 1, they give a piece, a board, a piece, and it gives them a boolean. So what we do is player 1. The player 1, if they won diagonal, if they in fact won horizontally, or if the player won vertically. Okay. Now that we have that, we can check to see if things are cool. Actually, here, type all. If I did not pieces open, not piece is open. Aha! I can make one final thing. Oh, it's gonna be so good. What's that? I'm gonna bring this all the way down. The tie game. We'll do that. We'll take the board and we'll produce a boolean return true if the game has become a tie. So a tie game. You take a board and you say this onto the board. What are you doing? Given a piece, you ask, are they not piece is open, piece, tie game. Okay, now, holy bejesus, we have a series of questions. Okay. If it's a tie game, okay? If it's a tie game, what are we gonna do? Put string ln, it's a tie. That's it. If player 1, so if a player 1, and if it's the player x, if x1, then actually I think I could do this. Something like that. I could do put string ln player x1. Or player 1 board player O. So if O1, put string ln player O1. Otherwise, this means no one has won. The game is still continuing. We're going to recursively call run tic-tac-toe of this board, and we're gonna swap players, player trip. And of course that doesn't work. Oh my god. Board. Oh, 124. Board. There we go. Oh my god, lads. I think I might have done it. Man. Okay. 5, 4. Oh. Yeah, you right. Okay. Now, check if anyone won. If not, loop again. Alright, 5. Oh, I wonder if that's it. I think this might be it. I think this might be the problem. Yeah, that's the problem, Al. Just change that, change position to index. I think that's it. Oh my god, it works. I still don't know why this is happening, but oh my god, it works. I'm so happy. That really makes me really happy. God, how big is this program? 143 lines. I mean, I'm sure there's ways could be smaller. Well, with that, since I'm basically a working, I mean, there's some weird bugs with the printing, but I made a working tic-tac-toe game, all in Haskell. So with that, I'm gonna go. Thank you very much for joining me. If you join me, boy, I am really happy with that. I don't even know how to describe how happy I am. GHC, let's compile that. Like, oh, something about that feels really nice. Like I was able to figure out how to place down pieces without directly modifying it. Like I thought that was really cool. And now I can play tic-tac-toe. Yeah. So that's cool.